Okay, so today we're going to start on exponential and logarithmic functions. Okay, so we're going to start with the definition of an exponential function. So an exponential function with a base, and we'll call the base, well, we'll represent it just by the letter b. Kind of leave it open to being a little bit of anything. It is defined by the equation either f of x equals b to the power of x, or b to the power of x equals y. Okay. Now in this case, your b, actually let me put a little underline there, where your b is positive, so it has to be greater than 0, and your b can't equal 1. Okay. And your exponent x is just any real number at all. Okay, so for example, let's say if you have f of x equals 2 to the power of x. In this case, your base would be 2. Or let's say if you had g of x is equal to 1/3 to the power of x. Then your base would be 1/3. But if you had something like, say f of x equals -4 to the power of x, your base can't be negative. So this wouldn't be an exponential function. Okay. Or if you had f of x, so bring that up a little bit, equals 1 to the power of x, remember it also can't be 1. So it can be any positive number except, well, 0 isn't positive, it's just non-negative. So it can be any number as long as it's positive, as long as it's positive and it's not equal to 1. It can be fractions, decimals, anything else. All right, any questions on that so far? Okay. Nope, you want to do it right. No. All right, so let's say if we do have, sorry about that, some base greater than 0 where it doesn't equal 1. Then if we have, let's say, the same base to the power of x equal, let's say, some base to the power of y, then that's equivalent to x equals y. So as long as you have the same base, the only way they will be equivalent is if the exponents are equal. Okay. So let's say, for example, if we wanted to solve for x, and we have 6 to the power of x equals 36. Okay, so the only thing we have to do is remember that 36 is just 6 squared. Okay, so instead of 6x equals 36, we will have 6x, well, 6 to the power of x equals 6 squared. Okay, so our bases are the same, which means this will be true when our exponents are equal. Okay, so that just means that x equals 2. All right, so any questions on that one? Okay, so let's say if we wanted to solve, let's say 64 to the power of x equals 16. Okay, so the same way we did up here, we can do the same thing down here. We just have to remember that we want to have those with the same base. Okay, so we have 64 is equal to 4 to the third power. 4 times 4 is 16. 16 times 4 is 64. And we also know that 16 is 4 squared. Okay, so instead of 64 to the power of x equals 16, we can just kind of separate that a little bit. We can rewrite that, and instead of 64, we can make that 4 to the third. So 4 to the third power to the power of x equals 4 squared. So if you remember the old exponent rule, if you have some a to the power of m, and that's raised to the power of n, then that's just a to the m times n. So that means 4 to the third power, that raised to the power of x, is just going to become 4 to the 3 times x equals 4 squared. Okay, so our bases are the same, which means this will only be true if our exponents are equal. Okay, so that means that 3x has to equal 2. If we divide both sides by 3, so x equals 2/3. All right, so any questions on that one? Remember, if at all possible, you want your bases to match. Bring that down a little bit. Alright, so for our next example, say if you wanted to solve 9 to the power of 2x plus 1 equals 81. Okay. So we have our 9 here, so we can turn that into a 9. Okay, so remember, the 81 is just 9 squared. Okay, so that means that 9 to the power of 2x plus 1 can equal 9 squared. Okay, so as long as your bases are the same, this will be equal if your exponents are equal. So that means 2x plus 1 has to equal 2. Okay, so if we subtract 1 from both sides, so minus 1, we'll have 2x equals 1. Divide both by 2, x equals 1/2. All right, so any questions on that one? All right. Okay, so we're now going to switch gears a little bit and go to the definition of logarithms. Okay, so let's say for all positive numbers, that we'll call b, where in this case b does not equal 1, and x is positive. Then our definition of y equals log of base b of x is equivalent to your base to the power of y equals x. Okay, so this is your base. And in this case, your base is over there. So really, if you get your base, raise it to the power of your answer, that will give you the x that's in there. Okay, so these mean really the exact same thing. So let's say, for example, I'll leave that up for a few seconds, make sure everyone's done. All right, so let's say if you wanted to convert from logarithms to exponents, or exponential form. Now I'll put that under there. Okay, so what if we just make a little chart there? So if we have our logarithmic equations over here, and we're going to convert them to our exponential equation, or exponential form. It's probably a more accurate description. And kind of draw a little line so nothing's mixed together. Okay, So remember, your logarithmic form is y equals log base b of x. And your exponential form is b to the power of y equals x. Okay. So what if we have log of base 2 of 8 equals 3? Okay. So you have your base to the power of your answer equals x. So you have b, actually let me switch that over so it matches the problem. So log base b of x equals y. Just switch them around a little bit. Okay, so you have b to the power of y equals x. Your base to the power of your y equals x. So you have 2 to the third power equals 8. Which is true. Okay, so what if you have log base 3 of 81 equals 4? You have your base to the power of your answer equals x, so 3 to the power of 4 equals 81. Okay, so what if we have log base 4 of 4 equals 1? Now sometimes you'll have a parentheses there, sometimes you won't, so I'll kind of mix them up. But you can usually tell when it's the x value, even if it's not a parentheses there. Okay, so you have your base to the power of your answer equals your x value, which in this case is 4. So 4 to the power of 1 equals 4. Okay, so what if we have log base 5 of 1 over 125 equals 3. I mean negative 3. Sorry about that. Okay. So you have your base to the power of your answer equals your x value. So 5 to the power of negative 3 equals 1 over 125. Which is true. All right, so any questions on that one? All right, so let's say now we convert from exponential to logarithms. And we'll do the same thing, just make a little separator. Okay, so we have our exponential form. Bring that up a little. And logarithmic form. Okay, so remember our exponential form, we're just kind of switching spaces there. So I have b to the power of y equals x. And we're going to convert it to log base b of x equals y. Okay, so draw a few to separate it a little bit. Okay, so what if we have 8 to the power of 0 equals 1? Okay. Remember, this is your base to the power of y equals 1, equals your x. So make a little side note here. Your base equals 8, your y equals 0, and your x equals 1. Okay, so that's log of base b, so that would be of base 8. Your x is equal to 1 equals your y, which is 0. So you have 8 to the power of 0 equals 1, 8 to the power of 0 equals 1. So you just did the whole thing, but in reverse. Okay, so what if we have 6 to the 1/3 power equals cube root of 6? Okay, make a little side note here. Your base is equal to 6. Your y is equal to 1/3. And your x is equal to cube root of 6. Okay, so you have log of base b, which is base 6, of your x, which is, bless you, cube root of 6, equals 1/3. So b to the power of y equals x, b to the power of y equals x. Okay, so let's do another one. Let's see if we have 6 to the power of -2 is equal to 1/36. Okay, just like before, this is your base, so that's your b is equal to 6. Your exponent, that's your y, so your y is equal to -2. And your x is equal to 1/36. Okay. So you have the log of base b, so that's base 6, of x, which is 1/36, equals y, which is -2. Okay. So they just kind of work on each other. All right. So any questions on those? All right. Leave that up for a few more seconds. All right. Okay, so let's say, for example, we wanted to solve for x. Okay, so let's say for problem A, we have a log base x of 25 is equal to 2. Say for problem B, we have a log of base 3 of x equals -3. And let's say for problem C, log with a base of 1/2 of 1/16 equals x. Okay. So they won't always have your b's and y's and x's. Sometimes there'll be an x here and x in different spots. So you really have to kind of know the actual way to switch it over. Okay, so for problem A, I'll just rewrite that. Log base x of 25 equals 2. Remember, that's your base. Even though it's an x here, that's how you can kind of call that your x if you want to. You can say more of your x position than the x value. And that's your y. Okay, so if you remember that log base b of x equals y is the exact same thing as b to the power of y equals x, then you have your base, which is x, to the power of your answer, which is y. So x squared equals your x position, which is 25. So if you want to change that to a b instead of an x, you could do that also. The x is just a variable. You can switch that to whatever you like. Okay, so you have x squared equals 25. So if you just square root both sides, x equals 5, and x equals negative 5. Remember, x is equal to plus or minus 5. But remember, the base has to be greater than 0. So since it has to be greater than 0, you can't use that one. So that's where those little definition rules come back. Base is greater than 0. Okay, so this is actually your only answer. All right, so any questions on that one? All right. So let's say for problem B, again, log base 3 of x equals negative 3. Remember, that's your base. Since that's in the x position, you can just go ahead and say that's your x. And that's your y. So if we convert that b to the power of y equals x, then that's going to give us 3 to the power of negative 3 equals x. Okay. So 3 to the power of negative 3, remember, whenever you have a negative exponent, you just bring it down to the denominator. So that's just 1 over 3 to the third power equals x. 3 to the third power is 3 times 3 is 9. 9 times 3 is 27. So you have 1 over 27 equals x. All right, so any questions on that so far? All right. Okay, so for problem C, which is log of base 1/2 of 1 over 1/16 equals x. Okay, remember your base is 1/2. Since the x is here, you can say this is your x position, or if you wanted to, you could just change that to y. Okay, so this is your x position, and that's actually your y. Okay, so remember, if we have b to the power of y equals x, then that means 1/2 to the power of x equals 1/16. Okay, and this is where we have to kind of look at the way we switched it up a little bit earlier. Because if you remember, that 1 over 16, you can make that into 1/2 to the third power. Fourth power, sorry about that. That would make it 1/8 if it was to the third. So it's to the fourth power. Okay. So you can change that 1/16 to 1/2 to the fourth power. So you have 1/2 to the power of x equals 1/2 to the fourth power. Okay. So your bases are both true, which means this will only be true